Picking up with our Chapter 6 practice test, I know I began number 17 in our Part 1 video. I'm going to start from scratch though. Whenever we have to factor, we should always look at all terms and see if there is a common factor, in fact the greatest common factor, that we could divide out. And when we see a 3, a 9, and a negative 12, we'd know that a 3 would divide into all three of those. As you look at x to the fifth, x to the third, and x, I can only take one x away from every item. And as we do that, as we divide out, we'll be left with x to the fourth plus 3x squared. And then negative 12 divided by 3, of course, would be negative 4. We've taken that x away. Right now I have a trinomial in the parentheses. And the middle term tells us we're looking for two numbers that should add to a 3. This constant of negative 4 tells us we should look for two numbers that could multiply to negative 4. And start with the multiplication. As we think about numbers that might multiply to negative 4, I know it's very typical for kids to want to think about 2 and 2, because 2 times 2 is certainly going to be a 4, but when you add or subtract a 2 and a negative 2 together, there's no way you could get a 3. Instead, there's another way you could multiply to a 4, and that's with a 4 and a 1. Now granted, you need one of these numbers to be negative to multiply to negative 4, but we also have to we have to add these two numbers to get a positive 3. So I need to multiply two numbers to get negative 4 and yet add to 3. We've talked a lot in class about how the larger number controls the sign when you add two sign numbers together. We're adding to something positive. We want our larger number to be a positive. So I have a positive 4 and a negative 1. 4 plus negative 1 is 3. 4 times negative 1 is negative 4. What does that tell us? Well, we'll break this up not into an x and an x, but x squared and x squared. We'd have a plus 4 and a minus 1. Now the x squared plus 4 cannot break down any further. A sum of squares can never factor any further, but a difference of squares, the subtraction of squares, can. This becomes x plus 1 and x minus 1. So that's actually going to be our final answer here. I'm just going to jot that down real quickly. So we look at number 18. We see a difference of squares. So we can immediately write a 4 times a 4 is 16, but we'll need x squared and x squared to be able to multiply to x to the 4th. We'll have a 1 and a 1, make this a plus, make this a minus. Now again, a sum of squares cannot break down. 4x squared plus 1 we leave alone. But 4x squared minus 1 can continue to break down. That is a difference of squares. This would be 2x and 2x. Of course, we'd need a plus 1 and a minus 1. And that's as far as we can go. So when you just see two terms that you have to factor, they're being subtracted like we have right here, that's really telling you to try a difference of squares. For number 19, well, this is a 4-term problem. There are 4 individual items. Let's try factoring by grouping. Just look at these first two. Pull out x squared. We'll be left with x plus 5. So we look at these last two. Maybe divide out a negative 4. We've talked a lot in class how this second parenthesis is going to be identical. You're going to have x plus 5 there. That can be a tremendous help as we proceed. Divide out a negative 4, and you will see negative 20 divided by negative 4 is a plus 5. If you're ever wondering if you've done this division correctly, you can redistribute, remultiply that in. But once you see these two parentheses are the same, then we can pull that x plus 5 out in front. We'll be left here with x squared minus 4. Well, the x squared minus 4 is a difference of squares. Here we go again. And that, thankfully, can factor to x plus 2 and x minus 2. And that's going to complete that third page. So we just have one last page to take a look at. Let's flip over to number 20. And in all honesty, what you'd like to do is get 0 on one side. So let's add 28x to both sides. Big difference here, of course, is we have an equation. The previous problems never had that equal sign. You never had any equation whatsoever. Here, we will factor. We're going to solve by factoring, but we're going to take our factors and then wind up setting them equal to 0. Well, what can I divide out from a 2, negative 18, and 28? You might guess we might try a 2. I can also divide out an x. So I'll have x to the 4th. Negative 18 divided by 2 is 9. Take away 1x from x cubed, you'll have x squared. And 28 divided by 2 is just a 14, and you won't have an x any longer. Well, you might guess we're looking for two numbers that will add to negative 9, and yet at the same time multiply to 14. Definitely focus on how you are multiplying. Multiplying to 14, you might think of 7 and 2, and you'd need both of them to be negative to be able to add to negative 9. So we'll have 2x, x squared minus 7, and x squared minus 2 equals 0. Our factoring technically is done, but now I'm going to set each of these groupings, the 2x, I'm going to set that equal to 0. Take x squared minus 7, set that equal to 0. And take x squared minus 2 and set that equal to 0. Solving, we'll get x is equal to 0 by dividing by 2 on both sides here. Be careful with the quadratic here, with this squared term. You add a 7, of course. You can take your square roots, but there are 2 of them. You'll have plus or minus radical 7. We'll do the same thing right here. Add a 2. And you'll have x squared is equal to 2, so take your square roots, you'd get x is plus or minus radical 2. So there are 5 answers in this problem. Don't want you to lose sight of that. The plus or minus indicates a positive and a negative. Like we were saying earlier, the highest power, the degree, will tell us how many answers we'll have. For number 21, it's minus an x from both sides, minus a 5 from both sides. And you'll see that you have 4 terms. This might seem especially likely that we're going to factor by grouping, and we will. For our first 2 terms, let's factor out x squared. You'll be left with x plus 5. For our last 2 terms, again, remember that you want to have x plus 5 in these parentheses as well. If you factor out negative 1, that will do the trick. And then very quickly, pull out an x plus 5. You'll have x squared minus 1 then. And x squared minus 1 is a difference of squares. Here that comes again. You have x plus 1, x minus 1. And my goodness, once again, you can set these 3 factors equal to 0 and solve. As you do that, you can minus a 5 from both sides. You get x equals negative 5. Minus a 1, you'll get x equals negative 1. Add a 1, and you'll get x is equal to positive 1. So you're going to be left quickly now with the 3 answers of positive 1, negative 1, and negative 5. Last problem. Very much a technology problem at that. We're going to use our calculator. We'll bring up our y equals and type in that left-hand side. X to the 3rd minus 2x squared, then a plus 4. Let's graph this in a standard window. Hit zoom 6. The solution here is going to be where your curve crosses the x-axis. And it looks, you can see my cursor right here, looking like we're pretty close to negative 1. What we'll do to find that, though, is hit second calculator, second trace, and we're going to use the 0 tool. The left bound, you can very easily type in -10. Right bound, we can type in +10. The guess, personally, I think it looks very close to the x value of -1. It looks like on the x-axis we're super close to that. And we are about -1.13. Hope that helps.